Title of the first section is Find the Sum of an infinite geometric sequence. The formula for this section is S, the sum, and since it's an infinite geometric sequence, there's no particular term number, it's the sum of all the terms. A1 divided by 1 minus r. And this equation only works when negative 1 is less than r is less than positive 1. For an infinite geometric sequence, which will be a sequence that continues forever, when the rate is between negative 1 and positive 1, the terms keep getting smaller and smaller, so we can approximate the sum of the entire sequence. If r is less than negative 1 or bigger than 1, the terms will continue to get bigger and bigger, and if the terms grow, we cannot approximate the sum. So the rate has to be between negative 1 and positive 1. The first problem we'll solve, a sub 1 equals 4, and the rate equals 5 over 7. So with the first term being 4, each term after that for the geometric sequence gets multiplied by 5 over 7, which again each term will get smaller and smaller, and we can use the formula to find or approximate the sum. So the sum of all the terms would be 4 divided by 1 minus 5 over 7, which is equal to 4. 1 minus 5 over 7 would be 2 over 7. And instead of dividing by 2 over 7ths, we can multiply by the reciprocal, 7 over 2. 4 times 7 would be 28, and 28 divided by 2 would be 14. So the sum of all the terms in the infinite geometric sequence is approximately or equal to 14. Second question and last question for this section. The sequence is 1/2 plus 3 over 8 plus 9 over 32 plus ... as the sequence continues on. For this equation, we need the first term, a sub 1, which is the first number, 1/2. And we also need the rate, which we can find by taking the second number divided by the first number. So 3 over 8 divided by 1/2. And again, instead of dividing by 1/2, we can multiply by the reciprocal, 2 over 1, which would equal 6 over 8, which reduces to 3/4. Using the equation, the sum of all the terms in the infinite geometric sequence, a sub 1 would be 1/2 divided by 1 minus r, or 1 minus 3/4. 1/2 would stay the same. 1 minus 3/4 would be 1/4. And we can multiply by the reciprocal, which will give us 4 over 2, or just 2. So the sum of all the terms in this sequence would equal 2. Title of the next section is Write a decimal as a fraction. In this section, we'll take a decimal and rewrite that decimal as a fraction. First decimal we'll look at is 0.9. 0.9 is a decimal that terminates or ends, writing a terminating decimal as a fraction. The number 9 we put as top of the fraction for the numerator, and the first decimal place is the tenths place, so 0.9 is 9 tenths, or the fraction would be 9 tenths. Second question and second decimal, 0.7 with a line above the 7. A line above a decimal means this decimal repeats. So we'll change the decimal 0.7, which means these 7s will continue on. We'll change that to a fraction. Rewriting this, 0.7 with the line on top would be 0.7777. And I'll put ... as these 7s continue on forever. We can write each number as a fraction, taking the first 7. The first 7 would be 7 over the placeholder value, which is 10. So 0.7 would be 7 over 10. And what we can do is add to that each additional 7 afterwards. The second 7 would be 7. And the second decimal place, first decimal place would be the tenths. Second decimal place would be the hundredths. So the first 7 is 7 over 10. The second 7 is 7 over 100, or 7 hundredths. If we continue, the next 7, the place values, we have the tenths, the hundredths, and then the thousandths. So the third 7 would be 7 over 1,000. Put a plus sign and then ... This would continue on as we'll have 7 over 10,000, 7 over 100,000, so on and so forth. Looking at these fractions represent a geometric sequence. Looking at the top numbers, the 7 would stay the same for every fraction, and the denominator going from 10, 100 to 1,000. Each denominator is being multiplied by 10. So the rate for this geometric sequence would be 1, since the 7 stay the same, multiplying by 1 each time, and the denominator we're multiplying by 10 each time. A1, again, the first value, the first fraction, will be 7 over 10. Once we have the rate and the first term, we can use the formula from the previous section. The sum of the infinite geometric sequence equals A1, which is 7 over 10, divided by 1 minus r. In this case, r is 1 over 10. Solving from here, 7 tenths would stay the same. 1 minus 1 tenth would be 9 tenths. And we have 7 tenths divided by 9 tenths. Instead of dividing by 9 over 10, we can multiply by the reciprocal, which would be 10 over 9. 7 over 10 times 10 over 9. If you wanted to, you could cross cancel the tens, and you'd be left with the final answer, the sum, 7 over 9. So looking back at the question, the decimal 0.7, where the 7's continue on, can be written as a fraction as 7 over 9. And the last problem for the section, last decimal, is 0.36, and the line will go on top of the 3 and the 6. The line again above a decimal means the decimal repeats, so we could rewrite this fraction or this decimal as 0.36, then the 36 repeats forever and ever afterwards, and we'll put ... as the decimal continues and does not terminate. Same steps as the previous problem. We can change each part of this as a fraction. If we have two numbers, 36, we'll take both of those for the fraction, 36. And the decimal place for the 36 will be the second decimal, The 3 is the tenths place, the 6 is the 100ths place. So the first 36 will be 36 over 100. And again, we can add to that each 36 as a separate fraction. The second 36, if you count the placeholders, tenths, hundredths, thousandths, and 10,000ths, the second 36 would be over 10,000. And one more we'll continue on, 36. The third 36, counting the decimal spots, we have the tenths, hundredths, thousandths, 10,000ths, 100,000ths, and millionths. So the third 36 would be 36 over a million. After this, we can put ... as the fractions would continue on forever. Again, for the equation for the sum, we'll need the rate. Again, looking at the fractions, the 36 will stay the same for each fraction. So that means we're multiplying the numerator by 1. The denominator, we go from 100 to 10,000 to 1 million. If you look at the zeros that are added on, we're adding on 2 zeros each time. If we're adding on 2 zeros, that means we're multiplying by 100. So the rate for the sequence is 1 over 100. And A1, again, the first term, the first fraction, 36 over 100. Using the formula again, find the sum of an infinite geometric sequence. Starting with A1, which is 36 over 100, and dividing by 1 minus the rate, which would be 1 minus 1 over 100. Simplifying, 36 over 100 will stay the same, divided by 1 minus 1 over 100 would be 99 over 100. And again, we can multiply by the reciprocal, which would be 100 over 99. And again, we can cross cancel the 100ths. So we're left with the sum of 36 over 99. Reducing fractions, 36 and 99. We can divide each of those by 9. So our final fraction would be 36 divided by 9, which would be 4. And 99 divided by 9 would be 11. So looking back at the original decimal, 0.36, where the 36 repeats, that can be written as a fraction of 4 over 11.